on the topic equation of motion. Today we are going to learn how can we derive the equation of motion v is equal to u plus at. V is equal to u plus at, which belongs to equation of motion in terms of velocity time relation. Velocity time relation, v is equal to u plus at. Let's derive v is equal to u plus at. So first we want to draw the graph. First we want to draw the velocity time graph of an object moving with uniform acceleration. First we want to draw velocity time graph of an object moving with uniform acceleration. From the graph we can derive the relation velocity time relation v is equal to u plus at. So let's draw the graph. The x-axis we can plot the quantity time, and in the y-axis we can plot the quantity velocity, and the object is moving with uniform acceleration, so the graph will be like this. Okay, this is the origin O. So it is the initial velocity. It is the initial velocity of the object. This is the final velocity of the object. Initial velocity, and this is the final velocity. So we can take this point as A, this point as A, and this point as B, this point as B. So from B we can draw two perpendicular lines like this, two perpendicular lines from B and downwards. Okay, so it is the initial point. So here it is the initial velocity u, and here is the final velocity v. Initial velocity u, final velocity v. So here we can name E, the point E. And to BE we can draw a parallel line like this. We can draw a parallel line, and here we can name D, and here we can name C. Okay, so it's all about the graph. Velocity time graph of an object moving with uniform acceleration. So this is the graph. Here is the initial velocity D. So this is all about the graph, velocity time graph of an object moving with uniform acceleration. Here is the initial velocity of the object, and here is the final velocity v. Okay, I think all of you clear about graph. So from the graph we can write BC is equal to, from the graph we can write BC. BC is equal to BD plus DC. plus DC. From the graph we can write BC is equal to BD plus DC. This DC is parallel to OA. Both are equal. So we can write BC is equal to BD plus OA. Because DC is equal to OA. So we can write OA. And from the graph, the point B gives the final velocity V. So this area gives the BC is equal to velocity, final velocity V. So instead of BC we can write final velocity V is equal to BD plus, what is OA? OA is the initial velocity U. OA is the initial velocity U. Okay. So V is equal to BD plus U. From this we will get BD is equal to V minus U. BD is equal to V minus U. We can put the equation BD is equal to V minus U as equation 1. BD is equal to V minus U as equation 1. Okay. And we know acceleration A is equal to, what's the formula for acceleration? Acceleration A is equal to change in velocity divided by time. So change in velocity by time. Change in velocity, acceleration is equal to change in velocity by time. Okay. Acceleration is equal to change in velocity by time. From the graph, how can we represent change in velocity? From the graph, how can we represent change in velocity? This is the initial velocity, this is the final velocity. So this part is the change in velocity. This part is the change in velocity. So BD is the change in velocity. So we can write A is equal to change in velocity BD divided by, what is the time? Time is AD. Time is AD. Time is AD. This line AD is parallel to OC. So in the place of AD we can write OC. So this equation becomes A is equal to BD by OC. A is equal to BD by OC. What is OC? OC is the time taken. What is OC? OC is the time taken T. So here we can write A is equal to BD by OC is time. So BD by T. Therefore, from this equation BD is equal to A into T. BD is equal to A into T. Mark this equation as equation 2. Mark this equation as equation 2. Then comparing equation 1 and 2. Comparing equation 1 and equation 2. The LHS are equal. BD, BD. LHS are equal, so we can equate RHS. So here V minus U. V minus U is equal to here AT. V minus U is equal to AT. From this equation, we will get V is equal to U plus V is equal to U plus AT, and this is our final relation. This is the equation of motion. V is equal to U plus AT in terms of velocity and time, and this is known as velocity time relation. V is equal to U plus AT. We can put the formula in a box. So what's the final relation? V is equal to U plus U plus AT. So in this class, we derived the equation of motion in terms of velocity time relation, that is V is equal to U plus AT. First, what's the first step? First we want to draw the graph, then do these steps, then equate equation 1 and 2. Finally we will get V is equal to U plus AT. So this is a simple derivation. So all of you complete your notes and study, and if you like, and also share this class with your friends. So see you in our next class. Thank you.